Hi and welcome. When I was in elementary and high school, the literature teachers would often have me read my essays in front of the whole class, and that was for two reasons. The first one was that they thought that my essays were so good, exemplary, and the other reason is that they couldn't read my handwriting. So apologies for the 3-year-old handwriting. This is as good as it gets, but I will walk you through all that. And in this video I will talk about what I do on every frame and every bicycle that I get a hold of, that I get into possession, regardless of whether it is a new bicycle or a used bicycle or a new or used frame. That's what I do. That's what I recommend all the people who bring their bicycles for me to service to do, regardless of whether I'm charging for it or not. So I will discuss and explain some things that will save you a lot of headache in the long run, and I think they are a must. You cannot reasonably expect bicycle shops to do that for you, or people who assemble new bicycles when you are buying a new bicycle, even if it is from a local bicycle shop. If you want someone else to do it for you, you would need to probably explicitly ask for it and probably pay for it more than for normal bicycle assembly. But again, in my experience over the past decades, it has saved me a lot of headache, and it's well worth it, and I don't mind doing it. I always do it. So what we are talking about, basically, it boils down to putting anti-seize paste on everything that is mounted to the frame. So every bolt, bottom bracket, seat post, headset cups, put some mounting seize paste, anti-seize or mounting paste that works as an anti-seize on that assembly, and that will enable you to unscrew it anytime in the future that you wish. So that's one thing. And another thing is to make sure that all the assemblies are faced, or the threads are clean, and all the assemblies are parallel to each other. I will show and explain everything. This is just a brief overview. By the end of the video I will also discuss carbon fiber frames and parts. They have a bit more caveats. So in this video, basically the whole video will be about the details and the caveats, so that you don't create problems for yourself, but instead help yourself. So let us get on with it. As all my videos, this one will have a table of contents so that you can skip to the parts of interest. This first section will be called the introduction, of course. And now let us begin. Anti-seize. Anti-seize is, I have an article about that. I will put it in the video's description, and maybe make it pop up in your top right hand corner if I don't forget when I upload this. Anyway, this is the anti-seize paste of choice that I used. It's made by a local company. It's not available anywhere outside of my country, and that's a story for a separate video. It's awesome. And this is copper grease. That's what it's colloquially called, and you can get it in any store. And I think that Motorex sells their copper grease that it is of a decent quality, and that is available on Amazon and in all the bicycle shops and stores, in many, not all, not by. So copper grease does the job. The main reason why I use the white one is the color, so the customers don't call me and say, hey, that bicycle you fixed, it started to rust. So it's easier to do this than to explain, but copper grease is more than good enough, and my article explains all the other catches and caveats. Basically you can use it. It's awesome. So what I mean by putting anti-seize paste is that every bolt that you would screw into your bicycle's frame, wherever you screw it into, you should first, let's see, you should first smear some anti-seize paste on the threads themselves, and on this face of the bolt that goes against the material. So using with or without washers or anything else, this is a must, and only then screw it into your bicycle frame and tightening it to the appropriate torque. I have also an article about tightening torques for bicycle parts. I'll put it in this video's description. So the same goes for seat post. Let me get a seat post. Here's one. So for this I usually just liberally smear it on, and sometimes even use my hand to distribute it evenly, and then insert my seat post into the frame. And so everything that is attached to the frame should use some anti-seize paste. And all this story is for metal bicycles and frames and metal parts: aluminium, steel, titanium. For carbon fiber, I'll discuss it at the end of the video, so to not forget that. That's an important caveat. So anyway, the combination of aluminium and steel, or aluminium and titanium even, is very tricky when it comes to galvanic corrosion. It basically makes things weld together through rusting, and it's very difficult to reassemble. So make your life easier, do this right from the start. That's one thing that I would suggest. Another thing is facing. What I mean by that, let me see. Here I have some bearing bottom bracket cups, and when you have bearings, if they are parallel, it's all good. But if your frame, when you mount the bearings, if this face is not parallel to the other face, but they are at a bit of an angle when you mount them, then your bearings will work with some extra load, and they will bind and wear more quickly, and you're more likely to get some creaks and screeching and everything. So the thing to do is to use special tools that I will show in a minute, to make sure that all these threads, if you have a threaded bottom bracket, are clean and parallel to each other. And then to use those threads as a guide, to use a tool to make sure that both of the sides are parallel to each other. If you're using the square taper bottom bracket, then you can only get away with only facing the right hand side, but for Holotech and similar bottom brackets, it's good to face both sides. I have videos showing how that tool is used and how the procedure goes, and I will put them in the video's description or make them pop up in your top right hand corner. I won't be taking much time for that, but I will show the tools while I'm talking about it. I think it's a good idea. So these things are used for driving the tools, and this is what the tools for cleaning the threads are like. For most modern threaded bottom brackets are still over the British standard. So the right hand side has a left thread, and here it's marked, the left threaded cutter. And the left hand side has a normal right thread, and here it's Unior makes these. I have an article about these Unior frame tools also. They're quite good. That's what I bought and use. And that has a right-handed side thread, and they have this guide to make sure that they're both aligned. And so what I usually do is start with one that's going easily and use that as a guide and alignment to screw in the other. And when they're both started by a few turns, then I turn them simultaneously with two of the tools like this to make sure that all the threads are clean and centered. And after I've done that, I go to the next phase, and that is that I insert these guiding cups. They also have the left and the right hand thread for the British standard. If you have Italian frame, you would need to get those for the Italian frame. So you get those screwed in all the way in so they are not protruding, and then use them as a guide for this tool that will pass through this and create some preload on the other end, and make sure that this is by 90 degrees compared to the direction of the threads. So it makes sure that both of these sides, when you make some cuts and remove some material, are at 90 degrees. Don't remove more than you need to. If it's removing material only from one section, that means that that section is a bit higher. And so when you get to the third 3/4 of a turn of removed material, that's enough for the bearing to sit tightly against it and to be nicely aligned. It has enough of an area to sit, and no need to remove any more material. It will only make you problems. So that's when it comes to facing. We have the similar situation with the headset. I have also a tool for that. I think I also have a video, at least in my native, on the BikeGremlin RS channel of how this is used. This is for the press fit cups, external 1 1/8 of an inch. This tool is designed for that, to make sure that the place where the bearing sits is of the optimal diameter. That's what this cutter is for, and this is used to face the other side. It has this cone and spring to create some preload and make sure that it's aligned, and then you use the same driver to face that. However, this is not something that I do often. I do this, but not this, because when I install headset cups and fork, and then when I lean the frame to be a bit towards the ground and rock the fork, if it moves back left and right in a few iterations, oscillations, and has no play, the bearings are good, I can feel it right away. But for the bottom bracket, it's more difficult to tell, because bottom brackets have a lot of preload and they don't spin very easily if you set the preload properly. They shouldn't be spinning too easily, and then you cannot be sure if the bearings are okay or not until you notice that your bearings are lasting half the time that they normally do. Even then you're not sure, maybe it's because of some dirt intrusion or similar, so it's no problem, and I usually make sure that these are faced. And very often, since this is a very small length, it's more crucial. Even a small degree of error makes a huge difference. But here with head tubes, they're usually longer, and again, it's not critical, so no need to do things that you really don't have to and remove extra material without really having to. So my advice would be to not do that for the head tubes, but to definitely do it for the bottom brackets. That's what's worked for me well over the past years, and that's what I would say is my advice. And this leads us to the next topic, grease versus anti-seize. Many cyclists and mechanics will tell you that grease is very good to prevent stuff from seizing and etc. And it's not. Grease will keep things from seizing for up to 6 months. Everything after 6 months is as if you put it to dry. Don't take my word for it. You can use I don't have any pedals right now to show you, but you can put grease on the pedal threads before you screw them into your crank and ride the bicycle for 6 months or so, unscrew the pedals and see that they are bone dry. So the grease is very temporary measure, and if you do a complete bicycle overhaul once a year, grease will not cut it. You will be running for 6 months without any protection. It will only stay up to 6 months. For reasons that are beyond the scope of this video, I don't want to talk for hours. It's very hot and humid here, sorry. When it comes to carbon fiber, there are a lot of different recommendations by different manufacturers and different talks and similar. And when I talk about carbon fiber, I often hear people complaining that if I put some petroleum-based grease or anti-seize paste, it might damage carbon or similar. I don't know what happens if you put carbon fiber fork into diesel or petrol. I don't suppose it's very good, but with this anti-seize paste, the white stuff, I've had no problems over the years, and I put it when I install. If the headset cups are press fit, I put it there. If the bottom bracket is press fit, I put this and install it, and it works okay. I've never had any problems. I would expect the more widely available copper grease or copper anti-seize mounting paste to work in the same way, but I must say that I haven't tried it, because for years now I've been using the white stuff for every bicycle that I work on. I use this only for motorcycle where the hot temperature is present, so this is for over 1000 degrees Celsius resistance, so it makes sense. For the rest stuff, it's easier to use the non-rust looking stuff, so I cannot really say, but I would dare to put that on my bicycle if it were my bicycle, if I thought that carbon fiber bicycle is a good idea. I have also a video about that. Let me continue. So some manufacturers recommend that you put some special glue with some special activating agent for your bottom brackets. I suppose that may be a good idea if you have problems with screeching and similar. If the frame is built properly to proper tolerances, I have never had any problems using anti-seize even on carbon fiber frames. And for the screechy ones that are out of tolerance, there is I will put a link to the website. Hambini is the manufacturer, the man who builds those inserts and adapters that can often solve problems, and that is, as far as I know, the best or the least best solution for improperly built carbon fiber frames bottom brackets. For the headsets, I don't know what solution is, so if your headset is a bit not faced properly with a carbon fiber frame, maybe take it to a carbon fiber frame repair shop, but I haven't had experience with that. Another important caveat when it comes to carbon fiber is the seat posts and mounting carbon fiber handlebars and similar. For those, you must not use grease or even any of these mounting pastes, anti-seize pastes, because carbon fiber parts are not very resistant to compression from the sides. If you take a carbon fiber tube and compress it, it will crack. So in order to reduce the amount of pressure but to increase friction, there is a special paste for carbon fiber. I will show it, just need to get here, just a second. This is what carbon fiber mounting paste looks like. It has like some sort of gel with some pieces of sand. It's very rough to the touch. I'm not sure if camera can show it, but it's very rough to the touch. And those pieces of sand, silicone, whatever they put, it creates extra friction. So with lower clamping force, you can keep the seat post from sliding and keep your handlebars from turning. So it's a good idea for carbon fiber. It's the only option, and it's highly recommended that you use the carbon fiber mounting paste. That's also mentioned with the shopping recommendations in my carbon fiber, in my mounting paste article that I mentioned. So for the seat post and for the handlebars, use that. But for the stem, when you clamp it to the steerer tube, you must not use this, because from vibrations it gets down to the headset bearings and makes your headset feel roughly and get busted, the top bearing, relatively quickly. So for that, I would recommend a dry fit with all the downsides of that. Also for the carbon fiber steerers and for carbon fiber seat posts, if you get any sort of oil or grease, make sure to degrease them with some alcohol, the 96+% from supermarkets. It's available, at least in my country, to make sure that no grease is there, because if you are forced to use too much clamping force because it's slipping, you will have problems and it will crack. That's what happens quite often. It's one of the common mistakes that owners of such parts make when they work on their bikes compared to aluminum or steel seat posts and handlebars. So those are some important catches and caveats to pay attention to. So basically what this whole procedure that I explained and talked about does is that you can ride for 4 or 5 years, even through the whole year, even through the winter when the roads are salty and everything. And when you need to remove something from your frame to replace a worn part, it will get stuck, but it will not get stuck so badly that you cannot unscrew it, or that if you manage to unscrew it with some those impact drills, they are awesome for those things, or with the impact screwdriver or some other method, the threads in the frame will not become damaged. Otherwise you risk damaging the threads in the frame, and then it's difficult to repair them, and if your frame itself gets damaged, it's often a total damage, because when you get a second frame, it's difficult to get the same model with the same mounts and all the standards for bottom brackets, wheels, even now they changed the axle width, the boost and non-boost and so on. So it creates a lot of problems, and using anti-seize mounting paste helps prevent a lot of that. And it's a joy to work on such bikes. When people bring me a bicycle that has the anti-seize paste applied and was ridden for 5 years. I forgot about the bicycle, but I can easily remove every bolt, and I'm very happy with what the previous mechanic did. And I've had 2 occasions where I completely forgot the owner and the bicycle, and I was just happy that I could easily work with a bike that was obviously neglected and hadn't seen service for years. And I told the customer that whoever did work on their bicycle did a great job. My work was very easy, and they should not have changed the mechanic. And then they said, but you did that bicycle. Anyway, I know it sounds like bragging, but my point that I want to make is that it really does make a difference. I can, how to say, confirm from first-hand experience how much of a difference it makes. And it's awesome. And it's something that I haven't seen people talk about. Practically no bicycle shop in my city, which is like the Serbian Amsterdam. Everyone rides a bicycle, and there are a ton of bicycle shops. I don't see any other bicycle mechanic using anti-seize for whatever reason. That is beyond me, but I swear by it, and I hope that sharing this experience helps at least one person. If you have any comments or questions, I would suggest to use BikeGremlin.net forum instead of using YouTube comments, so that the answers and the follow-up questions, and especially if you have any corrections or additions, can easily be searched and can help more people. That's the whole video. I think I haven't forgotten anything except this, the tricky part, drill a hole. Some steel frames, most steel frames have small holes that are used when the frames are not welded but glued together with the molten brass, if my English is correct for the term. So these are used to let the vapor escape, so that the brass can flow easily and create a good connection. And so there are often holes like this on bicycle frames made of steel, especially the high quality ones, and on forks made of steel. So let's see, this one has on the inside. So that is where the water can enter, and if you're riding through the winter or in wet conditions, some water entry will be unavoidable. And so it may be a good idea to mount the fork, mount the wheels, and see what the lowest section of your bottom bracket is when the bicycle is standing on the ground. And then, if you have that guide for the cables, there often is a hole to screw it in and to mount it. And once you've mounted it, I will turn the frame around now to show it better on camera. It's easier. I will pull it up and rotate it. So when you mount that, you might find a place when it's seated. Let's say that this is the lower section. You might find it a good idea to drill a hole somewhere there so that the water can drain. And I like to do that on the left hand side because I usually lean my bicycle to the left. So that would be someplace here, as close to this as possible, so that I don't get into any threads, but to have a hole for water draining. If you drill 4.2 millimeters, you can cut M5 threads, the metric M5 threads, into it, and have an option of easily closing the hole if you like, and unscrewing the bolt to let any water out should you wish to do that. And an important thing when doing that is to assure that when your headset cups are going into your frame, if you use something like this, to see how deep they go, so that the hole that you're drilling does not damage the threads on that section, so that you cannot screw this in easily, or so that this closes it up, and in that case it makes no sense to have the hole if it would be closed after all in the end. So those are some creative ideas. And for this last part, I cannot say with certainty that it is a good idea for every frame. It depends on the tube thickness and how it all aligns at the end. But for everything else that I said before this video, that is something that has given me good results for countless bicycles and frames, and I heartily recommend it. Now I hope I definitely haven't forgotten to mention anything, so thank you very much for watching, and I will see you in some other video. Cheers, stay cool.